I'm Larry Walther. This is principlesofaccounting.com, Chapter 12, and in this module we will be looking at the accounting for notes payable. Now, notes payable are formal short-term borrowings. They could be long-term, but we're going to focus on short-term here in this chapter. Formal short-term borrowings, usually evidenced by a specific written agreement or a promise to pay. Some terminology that's important to consider. The party who agrees to pay is termed the maker of the note. These notes are typically structured such that they are negotiable instruments, enabling the holder of the note to transfer it to another party for consideration. The note, in addition to the amount that's due on the note or the face amount of the note, would also typically involve an interest for the appropriate amount of time. So in this case, we have a maker of the note who has agreed to pay Bank Zone $10,000 plus interest of $400 on June 30th of 2000 x8. This interest is calculated or represents 8% of the $10,000 note for half a year. I'm assuming the note was created on January 1 and runs through June 30th. Here's a picture of the note. Here we have a promissory note for value received. The undersigned promises to pay to the order of Bank Zone the sum of $10,000. Okay, so $10,000 is the face amount of the note. The interest rate stated in the note is 8%. So we're going to pay the $10,000 along with annual interest of 8% on the unpaid balance. The note shall mature and be payable along with accrued interest on June 30th. So if we look at the duration or term of the note, it was issued or created on January 1, due and payable on June 30th, 6 months later. And so we would calculate the interest, $10,000, the principal of the note or the face of the note, times the 8% interest rate, times half a year or 6/12ths of a year to come up with $400. So the total amount due on this $10,000 note will be $10,400. I want to point out that a correct legal form for a note would typically be more expansive than the note I've just illustrated here. It would include things such as what happens in the event of default, who pays legal fees, requirements for demand and settlement, and so forth. Here's a journal entry for this note. First, the note was created on January 1, and we debited cash and credited notes payable $10,000. This records the note at its inception. On the payment date, June 30th, when we pay the $10,400 in cash, the credit to cash, that's offset with a $10,000 debit to the note payable that was established on January 1, and the $400 interest is also recorded at that time with a debit to interest expense. Let's revise our note just a bit and consider the entries that would be appropriate if the note were created on October 1. So on October 1, we're going to debit cash and credit note payable to reflect the $10,000 note. I'm going to assume at a December 31 year end. So we have October, November, and December goes by. 3 months go by, a half of the 6-month life of the note. So $200 of interest will have accrued. If we want to do the calculations, that's $10,000 times 8% times 1/4 of a year, that is 3 out of 12 months or 1/4 of a year, would give us the $200 interest expense. It's not being paid yet, however, because the payments aren't due on this note until maturity. So in this case, we're going to credit interest payable. On March 31, when the note is then paid, the $10,400 that's paid, $10,000 is debited to notes payable, $200 is debited to interest payable, that amount that was accrued at the end of the prior year, and $200 is recorded as interest expense, reflecting interest for January, February, and March, that 3-month period. Let's see how notes payable would appear in the balance sheet. Here's an example of a current liability section. I've got some other items like payables, salary payable, and so forth, but I'm showing a $10,000 note since it's due within the current operating cycle or current year, $10,000 note payable, and I've also got $200 of accrued interest. This is the December 31 disclosure showing both the note and the accumulated interest. The order of these current liabilities is typically according to their due dates from earliest to latest. Another alternative is based on maturity value from the largest to the smallest, however. Interest calculations. We've looked at that basically now. Some short-term borrowings may stipulate that a year is assumed to have 360 days. It might be justified as simplification of calculations, but lenders may use it to sort of take advantage of borrowers because, for example, if we had a $100,000 8% 180-day note, if we assumed a 360-day year, look at the calculations, 100,000 times 8% times 180 out of 360 days would yield 4,000 of interest expense, whereas if we took the 180 days divided by an assumed 365-day year, total interest would only come to $39.45. So it's very important in note agreements that you pay attention to the details. Are we going to assume a 360 or a 365-day year, for example? There's another method of allocating interest called rules of 78s that you really should try to avoid. It's based on the notion that a year has 12 months And the sum of 12, 12 plus 11 plus 10 plus 9, etc. through 1 equals 78. And under the rule of 78s, we would take the total interest and allocate 12 78ths of it to the first month, 11 78ths to the next month, and so forth. So what happens here? Assume we have a $100,000 8% note for 12 months. $8,000 would be the annual interest that's entailed, but if the borrower prepaid after only 2 months, using the rule of 78ths, what we would have is interest for that period of time, $23.59. That is 12 plus 11, the first month and the second month, 23 divided by 78 times the annual $8,000 interest would give you $23.59. If we had simply done this on a monthly basis, 2/12 of the $8,000 would be much less, $1,333. So rule of 78 tips the interest allocation to the front end of the note, probably an unfair method in many respects. Okay. We also need to consider simple versus compounding. Simple interest is just the loan amount or the principal times the interest rate times the time. Compound interest assumes that we pay interest on accumulating interest. Compounding can occur annually, quarterly, monthly, daily, or using calculus even continuously. Obviously, with compound interest, more accumulates during a similar period of time than you would under simple interest. The narrower the frequency of compounding, the greater the amount of the interest that is calculated to be associated with the note. Some notes will have interest paid up front. A note may be issued with interest included in the face value. You need to be careful with these instruments as well. They're also known as notes issued at a discount. Let's assume we have a $10,000 10% note for a year. 10% of 10,000 is 1,000. If this note is a note issued at a discount, the interest is taken out up front. So while we borrow $9,000, we simply repay $10,000 at maturity. If we look at the effect here, that's actually, while we said it was a 10% note, it's actually much higher. It's an 11.11% note because what we did is paid $1,000 of interest on $9,000 that we borrowed. So the true effective interest rate was much higher where the interest was taken by the lender up front. Here's journal entries for a discounted note. Initially, we credit notes payable $10,000. We debit cash $9,000. We left the $1,000 at the bank for prepaid interest, if you will, and we'll debit an account discount on note. Over the year, we'll then amortize the discount, credit the discount, and transfer it or recognize it as interest expense over the life of the borrowing. And at maturity, we simply repay the $10,000. So it looks like a fairly simple accounting, and it is indeed a fairly simple situation. The problem here is really having to do with the effective interest cost, the 10% interest rate, again, being much higher than it appears to be. Now, as you've seen, there are a number of tricks, if you will, to actually cause borrowing costs to be higher than they might appear to be to an unsophisticated borrower. Lenders can use unique interest calculations to tilt the benefit of a bargain to their advantage. As a result, statutes have increasingly required fuller disclosure or even limited certain practices on the parts of lenders. And not only that, lenders need to be sure when they engage in lending transactions to understand the legal rules that apply. There are actual rules that say that lenders who overcharge interest or violate other lending laws may lose the right to collect not only interest on the loans but the principal amount that's due. So these are attempts to sort of re-level the playing field, but fundamentally one should be very careful with their borrowing practices to make sure that they're entering into reasonable and fair agreements.